Okay, so welcome back to what we were discussing under nature of roots. This is for class 10th quadratic equations. So children from who are the students of class 10th, particularly with regards to quadratic equation and nature of roots, this lecture will be essential in terms of some of the question solving. Okay, so as you can see here, questions, it should be questions proving questions, that is on nature of roots. Okay, so now the reason why I'm taking up this particular lecture also on nature of roots is for those students who had actually gone through the previous lecture on nature of roots. They must have seen that we discussed the discriminant. Okay, which was let me just write it over here. D is equal to b square minus 4ac. So d is equal to b square minus 4ac. This was the discriminant. In fact, this is the portion which comes under the under root sign in Sridharacharya formula. Okay, so in what way will this lecture be different from that previous lecture? The difference would be that you can see the very first question that I have written over here. It has a quadratic equation, but it does not have numbers in it. Okay, so reason why such questions become difficult is because these are proving questions, number one, and then they do not involve numbers in them. Okay, so you have you can see over here a, b, c. These are some constants that they have used. Okay, along with the variable naturally, which is x. Okay, so this is an equation in x square, so this is a quadratic equation. Okay, so let us see how the first question goes. You see, we have if a and b and c are rational, so they have already told you that these three numbers are rational. We have to prove that the roots of this equation, this long equation that we have over here, you can see that it has an x square term, x term, and a constant term. So this is a quadratic equation. So we have to prove that the roots of this equation are also rational. Okay, now children, the first thing that you have to know before going ahead and solving this question is that what is the condition which makes the roots of a quadratic equation rational. So if you remember, children, rational number is a real number. Okay, it comes under the category of real number, but so do irrational numbers. So irrational and rational both come under the category of real number. So if you remember, children, that d portion, which was the portion in the under root sign, which was b square minus 4ac, you cannot simply say that this has to be greater than 0 for your roots to be rational, because you see, if it is greater than 0, let's say for example my discriminant value comes out to be let's say 23. Okay, so 23 is naturally greater than 0, but if you will put it in that Sridharacharya formula, you will get minus b plus minus under root of 23, which is going to be an irrational number. Okay, so which will eventually give your answer. Naturally, this is upon 2a. Okay, this is the formula for the root of roots of the quadratic equation. This is Sridharacharya formula. So I have shown you that d value, despite being greater than 0, can still give you the nature of roots as irrational. Okay, but here remember, the question is that your roots have to be rational, not just real, but they have to be rational. See, the roots will be real in this case also, but they will not be rational, because root 23 will be irrational, which will make the whole answer irrational. Okay, so the idea here is that along with being greater than 0, along with being a positive number, it should be a perfect square also. So naturally, if I take, now I am changing the value here, suppose d value comes out to be 25. Now 25 is also greater than 0, but the difference that it makes here, see children, root of 25 is 5, which is a rational number, which will make your roots rational. Okay, so even if your d is positive, still the roots can be irrational. Okay, so the question here is about rationality. So the discriminant value should be a perfect square. Okay, so this, keeping this in mind, let us proceed with our question. So the question here is already written, so we will quickly write the standard equation here. The standard equation is ax square plus bx plus c is equal to 0. Naturally, you must have understood why I have used capital A, capital B, capital C in the standard form. So this is the standard form of a quadratic equation. So you all must have understood why I am using capital letters, because the original equation already has small abc. Okay, so just so that you don't get confused. Okay, so my capital A becomes b minus c. So I am comparing now as we did last time. So we have b value as c minus a. Okay, again comparing the like terms. So this term has to be compared with this with this with this. Okay, so you have capital C, which is a minus b. Okay, so I have written down a, b and c. Now again, children, the main point here will be that we have to prove the roots are rational. So for rational, d, which is the discriminant, which is b square minus 4ac. Now children, I cannot use small letters bac here because I have used capital letters here. So let me write b square minus 4ac, which is my discriminant for this equation, should be greater than 0 also and a perfect square. Okay, just now I showed you the reason why it has to be perfect square also along with being positive is because, remember, you have to prove it rational. So just by proving them positive will not work, because a positive discriminant value can give you an irrational root also. Okay, so now let's check what is our b square minus 4ac. So this is my b. So b ka square will be c minus a whole square minus 4 times a into c. Now what is a? A is this. So you have b minus c here. What is c? C is a minus b, children. Okay, so I have done nothing else, just substituted the values of b, a and c from this particular line. Okay, so now let me see. Squaring this up, you have c square. Let me write a square first. So a square plus c square minus 2ac will be the expansion of this portion. Then now I'm going to expand this. You can do that in your own free time. So I'll do that 4b into a, so that gives me 4ab, then minus minus becomes plus 4b square, then you have plus 4ac, then you have minus 4bc. Okay, so I have expanded this these two brackets and this 4 all together. You can just check later on. So this is my b square minus 4ac. Let me just simplify this so that what can be cancelled. Let's see. So you have this minus 2ac and this plus 4ac, which is going to give you plus 2ac. Okay, so what I'm going to do here now is I'm going to in a separate line I'm going to just write down this particular portion after simplification. So it is a square plus this term. Okay, so I'll keep underlining this term. I have used this term is this. Okay, and then comes the c square term. So I'll write this. So all these square terms I have put together. Okay, so they have gone. Now what am I left with? I am left with this term minus 4ab, then comes this minus 4bc, and then comes this last term plus 2ac. Okay, so this is what I have got. Now children, till here things are quite simple, but after this you will have to be a little intelligent in terms of analyzing what is written in terms of the expanded formula of something. Now you see, you have the square terms for all A, B, C. You see, A also has a square, B also has a square, C also has a square. So A square plus 4B square plus C square should give you an idea that it could be an overall square of A, B, C with some signs in between. Okay, so that is the first idea that you get. Now you see, whenever you do the squaring of A, B, C, suppose I'll show you an example here. A plus B plus C, suppose you do a whole square of this. So do you only get A square plus B square plus C square? No, you get 2AB plus 2BC plus so on and so forth. So similarly, these three terms are also according to that. So what I'm going to do here is, I'm going to check, children. You see, out of these three terms, only term which is positive is the one which has A and C in it. Okay, so that gives me a clear indication that when I use A, B and C ka square, then where should I have a positive sign? I should have a positive sign with A and with C. So C will come with a positive sign and A naturally comes with a positive sign here. But can I put a positive here also? No. Because you see, if I put a positive here, then A, B term will also become positive. Whereas you can see here that A, B term has a negative in it. Okay. So the first thing is that here it should be a negative. Same thing you can see with BC also. BC term also has a negative sign. So if you put a plus here, BC will give you a positive BC. So that is why I am putting a minus. Now comes the number. You see, with AC you have a number 2. So A and C, you will not put any coefficient here, because when you square you will naturally get 2AC. Okay. But you can see very clearly in AB term and BC term there is a 4. So that is the reason why you have to put a 2 here, so that when you square this, 2 square will become 4, or 2 times 2AB will give you 4AB with a negative sign. Okay, you are understanding what I am trying to say? See, this A whole square will give you this term. Okay, now if I don't put up 2 here, then this will simply give me a B square. I do not want only B square, I want 4B square. So that is the reason I am putting a 2 here, because 2 square will give me a 4. And why should I get a plus here? How should I get a plus here? Naturally, because minus 2B whole square, square of a minus is always positive. Similarly, when this term is squared, you get a C square. Do you need a 2 here? No, because had it been 2C whole square, it should have been 4C square. No, but here it is C square only. You understand what I'm telling you? So this is how you write the numbers, and this is how you put the signs. These three terms, this term, this term and this term, the sign of these three terms will tell you where to put the plus and minus. Okay, so AC term does not have a minus, so both A and C will be positive. Wherever you see B, there is a minus, therefore you put a minus with B. So this is the logic that you will have to apply. Certainly this is not going to be an easy question. These kind of questions will need practice. So similarly, we are going to take up another question here. So let's see, we have another question from the book. Let's first write down the question. Okay, so we have okay, so the question, the second question here is that if this equation, now you see I can't write everything on the page here, on the screen here, so that we do not have any difficulty in the actual solution or the steps. We do not run short of space. So you see there is an x square term, there is an x term, and there is a constant term. Again, this is in terms of ABC. Okay, so this equation, the question is telling you that it has real and equal roots. Okay, so please keep that in mind. I am not writing it over here. The book says that in this quadratic equation you have real and equal roots. Now when you say real and equal roots, then the first condition is that your discriminant becomes 0. Okay, your d becomes 0. That is a straightforward rule that you follow. The discriminant value should be 0 if the roots have to be real and equal. Okay, so now let us see. Please note, children, that this condition is already given, so we will have to apply. We don't have to prove that. So applying that, what do you have to do? You have to show that either a is 0, which is small a over here, or a cube plus b cube plus c cube is equal to 3abc. This is what we have to prove. Okay, so let me again compare this with the standard equation. So I'm going to straight away write down the values of a, b and c. So let's see how that comes up. A is c square minus ab, b is minus 2 a square minus bc, okay, and your c, capital C, is nothing but b square minus ac. So let me put that in bracket so that you do not get confused. So these are the three values of a, b and c, assuming that we have a standard quadratic equation as ax square plus bx plus c. Okay, so my discriminant has to be 0. Now what is discriminant? We all know discriminant is nothing but b square minus 4ac. So I'm going to simply put the values. So b square I have to take. So let me write this over here. So I will have minus 2 a square minus bc whole square. Okay, so this is whole thing is b, so b square minus 4 times a, this is my a and this is my c. Okay, so b square minus 4ac is equal to 0. I know that the question has given me that. Okay, so we have to work with this, and now you have to proceed. So minus 2 whole square will certainly give you 4 with a plus sign, and then you will have, I am expanding this also, a square minus bc whole square, so that will be a4 plus b square c square minus 2 times this into this, so that will be a square bc. Okay, bracket close. Okay, minus 4 times. Okay, so first I will solve these two together so that you don't get confused. So you will have this into this, which will give you b square c square, then you will have this into this, which will give you minus ab cube, then this with this will give you minus ac cube, and then this with this will give you plus a square bc. Please be very careful. Somewhere you are getting square, somewhere you are getting cube, so you have to be careful with that. Okay, now take this 4 inside. So you have actually you shouldn't take this 4 inside. What you should do is, you can see this whole term is with a minus sign, so I can take this entire term to the right side and make it plus. Okay, so please note what I am doing, children. Now this I am going to remove and I am going to put equal to, because now you can imagine what has happened to the minus sign of this, because this has moved to the right side, so it has become plus. By doing that, you can see that 4 and 4 actually gets cancelled. So this is where you will have to be a little open in terms of the way you think. It's not that you are simply going to keep cancelling. You have to be on the lookout for things which are common, things which can be made positive, and so on and so forth. So you have okay, now what else can we do? We can have okay, there's nothing else to be cancelled, so I'm going to simply write down a to the power 4 plus b square c square minus 2 a square bc okay, equal to b square c square minus ab cube minus ac cube plus a square bc. This term and this term, children, they are same terms with the same sign but on the opposite ends of equal to sign, therefore they get cancelled. So you are left with a to the power 4 here. Then will this also get cancelled with something on the right side? Okay, you see, children, this is minus 2a square bc and this is plus a square bc. So if you leave out the the sign and the number, a square bc is present here also, a square bc is present, so these are like terms. Okay, so what you can do is this minus whole thing can be taken to the right side, so that is what exactly I'm going to do. So okay, and one more thing that I'll do, I'll take these three negative terms to the left side to make them plus. So you see, ab cube and plus ac cube. So I have taken these negative terms to the left side, made them plus, and similarly I'm going to take this negative term to the right to make it plus 3a square bc. Why 3? Here it was 2. When it went to the right, it became plus 2, and there was already 1 here. So 3a square bc. Okay, now children, there are only just a couple of steps remaining. So you see, remember, keep in mind what we have to prove. We have to prove that either a is 0 or a cube plus b cube plus c cube is equal to 3abc. Okay, so let us proceed. Now you see it is getting simplified. So you see, in this term over here and in this term over here, there is one thing that is common. A is appearing in all these three terms, so I am going to simply take out a from these three so that they become, naturally this was a power 4, 1 comes out, a cube it becomes, from here a comes out, b cube remains, from here a comes out, c cube remains, equal to 3 a b c into a. A square I have split into a, just so that you know there is an a here also, there is an a here also, so you can cancel it, but I will not prefer that you do that, because this is not a number, this is your variable. Okay, or rather you can use the term constant also for it, but it can have different numbers if you allot it different numbers. Okay, so the idea that I'm trying to tell you here is that what you can do here is that there is one way in which you can equate these two. You see, you already know that the left side and the right side, they are equal. Now how can they be equal? Either a becomes 0. What will happen if a becomes 0? See, a is outside the bracket, so when this number becomes 0, 0 into the bracket will give you a 0 on the left side. Similarly, a is outside here, so when a becomes 0, 0 into the bracket becomes 0. So 0 equal to 0. Proved. So that means first thing is that a is 0. Now what if a is not 0? Suppose you cancel this a. Okay. So what are you left with? You are left with a cube plus b cube plus c cube equal to 3abc. So this is the other condition that you had to see. This is the other condition that you had to prove. So either a will become 0, then left and right hand side will become same, or these two bracketed portions can become equal to each other so that they can get cancelled and a gets cancelled. So either this is true or this is true if this equation has real and equal roots. Okay children, so these were the two more difficult kind of questions given in the book. So I am sure that those who are in 10th standard will get help from this. Naturally, you'll have to sit down and practice on your own, because as you might have seen, there are a lot of squares and cubes and mixed terms that are there. So you have to be used to cancellations and simplifications. Thank you.